Hi students, in this video we are going to discuss about motion in a straight line. Motion in a straight line. Hi students, in this video we are going to discuss about a new chapter, that is motion in a straight line. Now go for some important points or introduction about this motion in a straight line. Now go for point number 1. The concept of the concept of differential coefficient or derivative defines velocity and acceleration Now once again I am repeating the point number 1. The concept of differential coefficient or derivative defines velocity and acceleration. Now point number 2. Suppose we have a quantity y. Take y whose value depends upon a single variable x, and is expressed by an equation defining y as some specific y has some specific function. Specific function of x. This is represented as y is equal to f of x. Y is equal to f of x. Once again, I am repeating this point, my dear students. Suppose we have a quantity y whose value depends on a single variable. Variable means continuously changing. Example, time is a variable, physical quantity. Now, a single variable x is a variable. Variable means now it is 1 second, after the 2 seconds, after the 3 seconds, like that. Variable x, and is expressed by an equation defining y as some specific functions of x. This is represented as y is equal to f of x. Once again I am repeating this point. Suppose we have a quantity y whose value depends upon a single variable x and is expressed by an equation defining y as some specific functions of x. This is represented as y is equal to f of x. Now, point number 3. The relationship drawing a graph of function y is equal to f of x. Y is equal to f of x regarding y and x as Cartesian coordinates. Now, once again I am explaining this point. The relationship drawing a graph function y is equal to f of x regarding y and x as Cartesian coordinates. Now, I would like to draw that graph. Please observe carefully. It is x-axis. Now, this is y-axis. Consider here it is x. This is x plus delta x. Now, the difference between these two is delta x. The difference between x and x plus delta x is delta x. Now, consider here there is one point on y-axis is y, and another one is y plus delta y plus delta y. Now take the difference between these two is delta y. The difference between these two is delta y. Now take x-axis and y-axis intersect. These two will be meet at a particular point. Now consider that point is P. That is P of x comma y. P of x comma y. Now take y plus delta y, and at the same time x plus delta x. These two will be intersect at a particular point. That is, say Q, where Q of x plus delta x coordinates, comma y plus delta y. These are the coordinates of this one. Now I draw a straight line between these two. Now if I can draw a curve or parabola which will be touches this one as, now if I can draw a straight line, a curved line, this curved line which indicate y is equal to f of x. Now you understood what is y is equal to f of x. Now we can draw a curved line between the P and Q which intersect at any point. This variable y is equal to f of x. Now I would like to draw a simple diagram for this one. That is, consider it is x, it is y, now I draw a straight line which makes an angle theta. It is y, it is x, it is y, it is y-axis, it is point y, it is x. Now if I can draw a line here, this is nothing but y is equal to f of x. Y is equal to f of x. That means just I simplify this diagram like this, or to make you understand, you will also write it as like this. Here it is y is equal to f of x. So the total complex diagram I make it into easy. Now I want to explain about the diagram. This is point number 4. Consider the point P on the curve What is the curve? The curve name is y is equal to f of x, y is equal f of x, whose coordinates whose coordinates are x comma y, and another point q, where coordinates are x plus delta x comma y plus delta y. Once again I am repeating this point. Consider the point P on the curve y is equal to f of x. It is a curve whose coordinates are x comma y, and another point Q where the coordinates are x plus delta x and y plus delta y. Now point number 5. My dear students, these points we already discussed on the graph. The slope of the line joining P and Q is given by tan theta is equal delta y by delta x, that is equal to what is delta y plus delta y minus y whole by delta x. Now once again tan theta is equal to delta y by delta x, that is equal to y plus delta y minus y by delta x. Now suppose point number 6. Suppose point Q moves along the curve towards P. This process comma delta y and delta x decreases and approach approach and approach 0. Once again I am repeating this point, my dear students. Point number 6. Suppose point Q moves along the curve towards P. So this process delta x and delta y decreases and approaches to 0. That means on y-axis x value is equal to 0. Now point number 7. This means that tan theta approaches the slope of the tangent at P denoted by M. Once again, I am repeating the point. This means that tan theta approaches the slope of the tangent at P denoted by small m. Now, point number 8. Where the m we also write as m is equal to limit delta x dash to 0 delta y by delta x is equal to limit delta x dash to 0 y plus delta y minus y whole by delta x. Once again I am repeating this point. M is equal to limit delta x down to 0, delta y by delta x is equal to limit delta x down to 0, y plus delta y minus y by delta x. Now go to the point number 9. The limit of the ratio, the derivative of the ratio delta y by delta x as delta x approaches zero is called the derivative of y with respect to x. Once again I am repeating this point, my dear students. The limit of the ratio delta y by delta x as delta x approaches to 0 is called the derivative of y with respect to the x. and is written as dy by dx. It represents the slope of the tangent. It represents the slope of the tangent. It represents the slope of the tangent. Line to the curve. Line to the curve. Line to the curve. Y is equal f of x. Line to the curve. Y is equal to f of x at the point x comma y. At the point x comma y. Once again I am repeating this point. It represents that means dy by dx, which represents the slope of the tangent line to the curve y is equal to f of x. We already saw the y is equal to f of x curve in the graph at the point x comma y. Now, point number 10. Since y is equal f of x, and y plus delta y is equal f of x plus delta x. Once again, since y is equal to f of x and y plus delta y is equal to obviously f of x plus delta x. Okay, now that means we can write the definition of the derivation as dy by dx is equal to derivation of f of x whole by dx, that is equal limit delta x tends to 0, delta y by delta x is equal to limit delta x tends to 0. What is this one? F of x plus delta x minus f of x whole by delta x. Once again, I am repeating this point, my dear students. Please observe carefully. Dy by dx we also write as d of f of x by dx. Now, that also we can write as limit delta x tends to 0, delta y by delta x that is equal to limit delta x tends to 0. What is delta y? F of x plus delta x minus f of x whole by, we can write it as delta x. So, my dear students, this is about introduction of motion in a straight line. Next class, we can discuss about some important formulas. However, thank you very much for watching this video. Thank you.